All right, let's get into it. We all use AI these days, but have you ever really stopped and wondered how it's actually made? And I mean, forget the code and the data centers for a minute. Think of it more like a recipe, an incredibly complex, multi-stage recipe for cooking up a digital mind. And today, we're heading straight into the kitchen.
So that's the big question, right? How is an AI like ChatGPT really put together? We're going to pull back the curtain and look at the whole process. We'll check out the raw ingredients, the revolutionary oven they're baked in, and even the final taste testing that makes them useful to us. This is the secret recipe, completely broken down. You know, any great dish starts with its ingredients. But for AI, the ingredients are just data. Trillions upon trillions of words and images. And here's the problem. These ingredients are scraped right off the open internet. And as we all know, the internet isn't exactly a sterile, clean kitchen. An AI model is fundamentally a direct reflection of what it consumes. Its skills, its quirks, its biases, its entire worldview comes from this initial diet. So let's take a closer look at what's actually on the menu. The main ingredient for pretty much every major AI model out there is a dataset called Common Crawl. And it's exactly what it sounds like. A nonprofit organization crawls billions and billions of web pages every month and just makes all that data available to the public. You can think of it as the ultimate bulk food store for the entire internet. And here's the reality of that bulk ingredient. Yeah, you get all the encyclopedias and the scientific papers in there, but you also get, well, all of this. It's the whole unfiltered internet. The good, the bad, and the very, very ugly, all poured directly into the same mixing bowl. And this is the foundation we're building on. But it's not just about quality. There's also a huge problem with balance. Just look at this breakdown. English absolutely dominates the dataset, making up almost half of the entire thing. It's more than 7 times bigger than the next closest language. This chart really puts that gap into perspective. You've got English way up there at nearly 46%. But then a language like Punjabi, which is spoken by over 100 million people, is so small it's basically a rounding error on the chart. It's just a tiny, tiny fraction of a percent. This massive imbalance in the ingredients creates a huge imbalance in the final AI's abilities. And really, it all boils down to this. Developers are forced to cook with the ingredients they have, not the ingredients they want. The result is an AI that's naturally incredibly fluent in the language of the English-speaking web, but it really struggles with almost everything else. Okay, so you've gathered all your messy ingredients. Now you need an oven. In the world of AI, the oven is the model architecture. It's the revolutionary design that actually bakes all that raw data into something that feels intelligent. The absolute game-changing invention here is something called the transformer architecture. Before transformers, models had to read text sequentially, one word at a time, just like us. But transformers, they can process the entire input all at once, in parallel. This was a monumental leap in speed and efficiency, and it's what makes today's massive models even possible. Now, just like in baking, there's a ratio you need to get right. How much data do you actually need for a certain size model? You can't just build a gigantic oven, a model with billions of parameters, and then just give it a tiny little bit of flour. You have to balance the ingredients with the size of your oven to get a good result. And believe it or not, researchers at DeepMind actually figured out the perfect recipe for this. It's a principle called the chinchilla scaling law. Think of it like a baker's ratio, but for AI. It basically tells us that to get the most bang for your buck, for every doubling of your model size, you also have to double the amount of data you train it on. It's all about that perfect balance. So, we've mixed our messy ingredients and we've baked them in our revolutionary oven. But what comes out is not a friendly chatbot. Oh no, it's a raw, incredibly powerful, but completely untamed digital beast. So the next step is the taste test, the process of aligning it with what we humans actually want. And this quote just nails the problem perfectly. A raw, pre-trained model is really just a glorified text completion engine. If you ask it, how do you make a pizza? It might just finish the sentence with, for a family of 6. It doesn't understand the idea of a conversation. It has to be taught how to be helpful. This taming process happens in a few stages. First, they give it tons of high-quality examples of good conversations to learn the basics. But then comes the really critical part, a process where humans literally act as taste testers. The AI generates a couple of different responses, and human reviewers just sit there and pick the better one.
over and over and over again. And through thousands of these little choices, the model starts to learn our preferences, and it develops that helpful, friendly personality that we all expect. This whole process has led the AI community to this really powerful and honestly slightly terrifying metaphor, the Shoggoth with a smiley face. The idea is that underneath everything, you have this immense, complex, and fundamentally alien intelligence that was trained on the pure chaos of the internet. That's the monster. And then right on top, we've painted this very thin, very polished, friendly layer of human preferences. The smiley face is what we all talk to. Okay, so we have a tamed model, but how does it actually decide what to say, word by word? This is the final step in our recipe, how the answer is actually served up. You could call it the final plating. Well, the process is called sampling. And for every single word it generates, the model calculates the probability for every possible next word in its vocabulary. Now, here's the key. It doesn't always pick the most likely word. It samples from the likely options. This is the crucial reason AI is probabilistic. It's playing the odds. It's not just following a rigid script. And we can actually control this process with a setting called temperature. Honestly, just think of it as a creativity knob. If you turn the temperature down low, the AI sticks to the most probable, safest words, and you get very consistent, predictable answers. But if you crank the temperature up, it starts taking more risks, sampling less likely words, which leads to more creative and sometimes completely nonsensical outputs. So why does any of this matter to you? Well, this one concept of sampling explains almost all of the weird behaviors we see in AI. It's why you get a different answer when you ask the same question twice. It's why AI hallucinates. It just samples a word that happens to lead it down a factually incorrect path. It's the source of both its brilliance and its nonsense. And that brings us to the most important takeaway here. If something has even a tiny, non-zero probability of being the next word, no matter how strange or wrong it is, the AI can generate it. The chance might be 1 in a billion, but it is never zero. And this brings us right back to that smiley face. For a model like ConstructGPT, which was a forerunner to ChatGPT, only 2%, just 2% of the entire compute budget was spent on post-training. That's the part that teaches it to be safe and helpful. The other 98% went into creating the raw, untamed beast. That friendly face is a very, very thin layer. So just think about that for a second. If that polite, helpful interface is just 2% of the total work, what are we really talking to when we chat with an AI? Are we talking to that friendly face, or are we just getting glimpses of the vast, chaotic, web-fed mind underneath? That is the real secret of the recipe.